Hi, and welcome to Allen High School's discussion of electrochemistry at the AP-IBHL1 level, which is the same as general chemistry at the college level. We are working on some free response reactions here, and this first one gives us a cell, and we want to note some key information here. For one, it says this is a spontaneous reaction. So we have to set up these half reactions so that the system will be a voltage producing system. And to do that, we need to look up the E0 values. The E0 value for the cadmium half reaction is minus 0.40, and for the silver half reaction, it's plus 0.80 volts. Now, when it's spontaneous, you want the most positive E0 to represent your reduction. So that means the silver side is my reduction and my cadmium is my oxidation. Now, if it wasn't spontaneous, I figure out what it wants to do spontaneous and flip it. And remember, while in cell notation, we always put oxidation on the left and reduction on the right, that's not always true for cells, so you've got to look carefully. All right, so that means that silver ion is accepting an electron to become silver, and cadmium is losing 2 electrons to become cadmium ion. It's being oxidized. When I get to the balanced reaction, I have to have my electrons balanced. So I have to multiply that by a 2. So my final answer is going to be 2 silver ions plus a cadmium yields 2 silvers plus the cadmium ion. And you can double check because your net ionic, notice this is net ionic, I paid no attention to those nitrates. The charge on both sides should be the same. So I have plus 2 on the right hand side and plus 2 on the left hand side. Now the next question says, what happens to anions? Now notice that the silver is plating out. Okay, so I'm losing positive ion here. And on this side, I'm forming cadmium, so I'm gaining positive ion over here. So to balance out that excess positive on the anode or oxidation side, the anodes are going to flow from the reduction cell or silver to the cadmium, the oxidation. And that's going to be true always. Okay, this is the cadmium. All right, so anions flow towards the anode side or the oxidation side. So you can kind of tell by the namesake. So any anions that are present, I'm going to pop some negatives over here to help counterbalance that positive flow. And so my justification is I form excess positive charge, which must be balanced by the negative flow. If it doesn't, the cell will stop. Okay, so that would be something of a justification there. Okay, now what if I took 3 molar silver nitrate and I added it to this side? Well, let me get that cell reaction because I need that to help us. So I have silver ion plus cadmium yields cadmium ion plus 2 silvers. Sorry about that. Plus 2 silvers. Okay, now you can use Le Chatelier principle. So if I increase my silver ion, I have too much reactant. And the way to get rid of that, or Q, remember, is going to be cadmium over my silver. So if I have too much reactant, my Q is too small, so I need to make more product. So it's going to shift to the product side. And since this is a spontaneous cell, shifting to the product means it's a voltage producing situation. Or since I produce voltage, I'm going to increase the voltage on this cell. Because I shifted it, another way to think of it is you could put plus your volts over here. So I'm shifting it in the voltage producing direction, so I'm going to increase my voltage. Now, another way to predict that is this way. E is going to be equal to E naught minus constants 0.0592 over N. They're both positive, log of Q. Well, that's my cadmium over my silver squared. Don't forget to square that. Now, if I increase my silver ion, that means that this number becomes less than 1. It was 1 to 1. And now it's going to become less than 1. The log of a number that's less than 1 is negative. So E naught minus a minus is going to be E naught plus a value. Oh, my Mimeo's all over the place today. Sorry about that. There we go. In other words, E naught's going to be increased. All right, so E ends up being greater than E naught. All right, let's go to the next one. What would happen if I added some solid silver chloride? Well, silver chloride is not part of the reaction, but if I put, sodium chloride into solution, I'm going to get sodium ion plus chloride ion. And you should know by now that if I add chloride to silver ion, I'm going to form solid silver chloride. So what that's going to do is decrease my concentration of silver ion. Now notice chloride does not precipitate the cadmium, so we don't have the same effect as we have on cadmium. So if we go back to our original reaction, 2 silver ions plus cadmium, 2 silvers plus cadmium ion, plus voltage. Remember, this is voltage producing. If I decrease my silver, I have a loss of reactant. I have to replace that by consuming product, so I'll shift to make more reactant. That's a voltage requiring direction, so my voltage will decrease because it's going to require voltage to go back the opposite way that was spontaneous. And you're pushing it against the spontaneity, and that's going to take energy to push it against what it naturally wants to do as a system. Now, another way to do that is, let me get myself a little bit of room here. So let's take a look at that again. You can also estimate that using the Nernst equation. So E is E naught, E naught, I don't know why I did that, 0.0591 over 2 log of cadmium over silver squared. Most common mistake I see with the Nernst equation is forgetting to square that. So if I decrease the silver ion, overall I get a number greater than 1. The log of a number greater than 1 is positive, so I have E naught minus a positive value. That means E is going to be less than E naught. Okay? Now, E is very, very tricky. What I'm doing when I add 20 mLs is I dilute both of these. So I'm just going to look at that log of Q. So cadmium 2 plus over silver ion squared. Now I've diluted both cells, right? But the factor here is by 1. The factor here, that dilution is magnified because it's silver ion squared. So the net effect is have a decrease in the denominator, which means that overall I end up with a number greater than 1, which the log of a value greater than 1 is positive, so I have E naught minus a positive value. So that tells me, that explains why my cell voltage decreases. Okay, so that is the first of our free response that's in your notes. And I'm going to hold off on the second one until the next video. So until then, this is signing off.